Hi, hello, namaskara. So, in this section of Structural Analysis 1 lecture series, we'll discuss something about sign convention, equilibrium equations, and difference between static, statically determinate structure and statically indeterminate structure. Statically indeterminate structures. We'll discuss the difference between them. Let's come to the sign convention first. First, let's take about the reactions. We know that if you're having hinge support, you'll be having two reactions, upward reactions and the vertical and horizontal reactions. For the roller support, we have reaction which is perpendicular to the plane of the support. This is very important. And for simple support, we have one vertical reaction, and for fixed support, we have vertical, horizontal reactions and the moment. So these are the reactions, and these reactions we are taking it as upward and towards right are positive, clockwise moment positive, anti-clockwise moment negative. Of course, downward force towards left are negative. So this is the sign convention we are following in case of reactions. Next we'll go for the shear forces. There are two cases in the case of shear forces. You need to understand that if I am taking shear force from left to right, you know that the shear force is nothing but algebraic sum of the forces from the left or from the right. If I am taking from left to right, upward forces, upward shear forces are positive, downward shear forces are negative. If I am going in the opposite way, that is, if I am taking the shear force values from right to left, upward forces will be negative, downward forces will be positive. Please remember that this is very important. When you are going from right to left, the sign changes. Then bending moment. Guys, you should not get confusions with the moment and bending moment. When I am going for bending moment, it has different meaning. When I am going for only moment, it has different meaning. We already discussed about if you are having moment clockwise, we are taking it as a positive. If you are having anti-clockwise moment, we are taking it as a negative. But when you are going for the bending moment, please observe here. If I am having any beam, let us take simply supported beam. If I am applying the load on this, whether it is point load or uniform distributed load, whatever it is, it will deflect like this. When it is deflecting like this we can call it as sagging. And when you are having cantilever, if I apply the load here, this deflect like this. That means it is deflecting like this. This is known as hogging. This is how the beam bends. This is the main reason for this. Sagging we are taking it as positive. Hogging we are taking it as negative. And one more thing you need to remember here, when you are going for the sagging, the tension zone will be at the bottom and compression zone will be at the top. And when you are in the case of hogging, tension zone is at the top, compression zone is at the bottom. Of course, you know that we are providing steel at the tension zone. Then we already discussed about the equilibrium equations. Once again, I'll explain. Please understand this because we are using this equilibrium equations conditions. Equilibrium equations are equations of equilibrium. So what are that? there are three main equations of equilibrium, but it is not same in all the cases. Please remember that sigma v is equal to 0, sigma h is equal to 0, and sigma m is equal to 0 in the case of two-dimensional plane frames. This is in the case of two-dimensional plane frames. You know that two-dimensional plane frames is nothing but if you are having two columns and one beam, this is 2D frame. So that for this we have sigma v is equal to 0, sigma h is equal to 0, sigma m is equal to 0. Of course, it is for beam also. Either this is the three equilibrium equations. When we have three-dimensional plane frames, three-dimensional frames are called as space frames. Three-dimensional frames are space frames when the structure is space. So that there we need to take sigma v is equal to 0, sigma h is equal to 0, and sigma z is equal to 0. So that means sigma v y direction, sigma h x direction, sigma z it is z direction. Of course, when you are having three-dimensional structure, we need to take like all these three dimensions, and we'll be having the moment in all the directions. Sigma my is equal to 0, sigma mx is equal to 0, sigma mz is equal to 0. That means algebraic sum of all the forces in x direction, y direction, and z direction, and the algebraic sum of all the moments should be equal to. If you understand equilibrium equations generally or practically, you should know like this. Just hold a pen, or if you are having any box, if you are holding like this box is not moving in this direction or is in this direction, that we should take it as sigma fx is equal to 0, or sigma h is equal to 0, or sigma fh is equal to 0. That means algebraic sum of all the forces acting in x direction or z horizontal direction should be equal to 0. That means it is not moving in any direction in the horizontal movement. And if you are going for the y direction, it is same as that. That means if you are adding the forces with their signs, you should get it is equal to 0. So that is the main thing you should understand with this. So after this, we should go for statically determinate structure and statically indeterminate structure. So already you may be knowing that, assuming that I am telling the word. So static, you know that the static is nothing but we are studying the subject or the effect of loads when the body is at rest. The body is at rest. So dynamic is nothing but when the body is moving. We are studying the load on the body, the effects of load on the body when the body is in motion. So most of the structures what we are studying are static. So that's why I am telling about statically determinate structure and statically indeterminate structure. Before going to study what are the difference between them, let's understand what is statically determinate structure and what is statically indeterminate structure. If I am going for statically determinate structures, any structure that can be analyzed by using equilibrium equations only. As I told you already, analysis is nothing but calculating the reactions, support reactions, or the stress resultants like the axial forces in case of trusses, shear forces, and bending moments in case of beams. Suppose if I take the simply supported beam, by using equilibrium equations which are there, three equilibrium equations, sigma Fy is equal to 0, sigma Fh is equal to 0, and sigma m is equal to 0. By using these three equilibrium equations alone, you can calculate all these things. I can calculate the support reactions, I can calculate the shear force, bending moment, and I can draw bending moment diagram. So that is the meaning of statically determinate structure. Statically determinate structures are the one which can be analyzed completely by using equilibrium equations alone. In other words, if I say the number of unknowns here are lesser or equal to, less than or equal to equilibrium equations. Already we have discussed equilibrium equations will be having 3 for plane frames, 6 for space frames. In case of space frames, if I am having number of unknowns 6, definitely you can call it as statically determinate structures. In case of plane frames, 2D plane frames, if the number of equilibrium equations are 3 and number of unknowns are less than or equal to 3, like this, it is called as statically determinate structures. In simple words, try to understand that statically determinate structures can be analyzed by using conditions of equilibrium equations alone, that are enough to analyze that. If not, if it is not possible to analyze by using equilibrium equations alone, we need to use some other methods which have been developed by various research, and that is known as statically indeterminate structure. So now you can see what are the differences between statically determinate structure and statically indeterminate structures. Let me write statically determinate structure here, and this side I'll write statically indeterminate structure. So first difference is these structures can be analyzed by using equilibrium equations alone. Equations alone. Here, this cannot be analyzed. Statically indeterminate structures cannot be analyzed by using equilibrium equations alone. By using equilibrium equations alone. That is the first difference. Second one, since the statically determinate structures are very simple, the stresses, no stresses caused due to change in temperature. Suppose if I am having a structure, if I am applying the load on that, the stresses will not be developed due to will not be developed due to change in temperature. So that means these are structures are very simple. There is no stresses developed due to change in temperature. And when you are going for this, definitely these stresses are developed due to change in temperature. And third one, there is no stresses caused due to lack of fit. If it is not fixed properly, the stresses will not be developed. Again, it is because of the simplicity in nature. The stresses will not be developed due to lack of fit. This comes in the case of railway tracks. I will be explaining that when we are going for that. The stresses are developed due to lack of fit. So these are the main differences between statically determinate structures and statically indeterminate structures. Then let's see what are the statically determinate structures, examples for them, for statically determinate as well as for statically indeterminate structure. So first one, if I am going for this, the simply supported beam. See, number of unknowns in this is, here it is one reaction and one reaction. So total number of reactions is 2 for this. Equilibrium equations available are 3. So this is statically determinate structure. Second one, let's go for cantilever. Number of unknowns are 3, that means 3 reactions at the fixed support. There is no reaction at the free end. So number of equations available are 3. So this is also statically determinate structures. One more example, let us take 3-hinged arch. So 3-hinged arch is a statically determinate structures. Remember this when we are solving the static indeterminacy and statically determinacy, static indeterminacy. So there you can understand what is 3-hinged arch, how to calculate all those things. And if you are going for 2-hinged arches, this is statically indeterminate structure. And when you are going for the propped cantilever, see cantilever with one support, number of unknowns in this case is, here it is 3, here it is 1, so total is 4, but equilibrium equations available are 3, so this is statically indeterminate structure. Next, if you are going for fixed beam, number of unknowns here it is 3, number of unknowns here it is 3, total number of unknowns is 6, but equilibrium equations available are only 3. So 6 minus 3 is 3. In fact, fixed beam is 3-degree indeterminate structure. So now you understood what is the difference between statically determinate structure and statically indeterminate structures. The main thing you need to understand is statically indeterminate structures are nothing but that cannot be analyzed by using equilibrium equations alone. Okay, we'll continue in the next session. So what we need to do, statically, how to calculate degree of static indeterminacy, or it is also called as degree of redundancy. We'll do that in the next class. Thank you.